All right, just a few more problems. We're on number 12 on interim test number 3. Mr. Ochoa's math students read a 2010 census report on the highest level of education attained by citizens of the United States. The table includes some of this data. Okay, so first off, reading around the table. Always be sure you read around the table. Highest level of education. So we've got these different categories, and these are all percent of population in 2010. So not a high school graduate is 11, high school graduate is 26.6. Some college or an associate's degree, that usually takes about 2 years, you can get one of those at Cuesta, is 31.8, which I rounded off to be 32%. Bachelor's degree is 19.6, that's about 20%. And a graduate or professional degree is 11%. The students conducted their own survey of 200 randomly selected adults based on the census data, which is the most reasonable prediction for the number of adults they surveyed who have some college or an associate's degree as their highest level of education. Okay, some college or an associate's degree as their highest level matches with this one. So that's 31.8, which is about 32%. Now this is of 200, so that means you're going to multiply, this is for percent, 100, so of 200, you could take that and double it. You could say 32 out of 100 equals what out of 200? It's about 64. Well, of our choices, which one is close to 64? Because remember, we rounded. Yep, 65 is the best choice. Mark it. Sometimes it's a little round thing, sometimes it's a little check mark. Whatever it is, mark that one. That was a normal type question. Cool. Number 13, Mason asks a random sample of both boys and girls how much time they had spent on math homework that week. Remember, practice makes you better. So, it's good that you have homework. Mason displayed his data in the box plots below. So these are called box and whiskers. The main part is the box and the whiskers stick out. So I've drawn on here a little bit. Determine if the statements below are true or false. Drag and drop either the true or false into the box next to each statement. So you're going to take either true or false and drag it into these 4 boxes. First one, the amount of time spent on homework is generally greater for the boys than for the girls. Okay, well, looking at it, the boys is further up on the scale than the girls just in general. So I'd say that's true. Go boys. The interquartile range for the girls is about 10 minutes more than the interquartile range for the boys. This one I found a little bit hard to see, hard to judge. Interquartile means the box. So the box here is this big for the boys, but it's going to be this big for the girls. So I had to kind of estimate going down here. The numbers didn't fall exactly, so I guesstimated right here to be about 23, and this about 48, whereas this was 25, and this was 40. So it seems like it's a little bit bigger by 3 here and about 7 here. So I'd say, yep, by about 10 seems to be right. So that is also true. Part 3. The data for the boys have a greater range of values than do the data for the girls. Okay, well, the range for the boys, the highest number is 65, the lowest is 20. If you follow the maximum and minimums down, so 65 minus 20 is 45, that's the range for the boys. For the girls, it's 60 down to 10. 60 minus 10 is 50, the range for the girls. So the data for the boys have a greater range. No, the boys have a range of 45, the girls have a range of 50. That would be false. And last, 50% of both boys and girls spent less than 35 minutes on their homework. 50% of both boys and girls spend less than 35 minutes on their homework. Okay, remember, each part is 25%. So 35 minutes of homework would be like right here. So this is 25% of the girls and another 25%. So yeah, 50% or less of the girls spend 50% of the girls spent less than 35 minutes on their homework. For the boys, it's even more because this little piece is 25%. This is another 25%, and it's a little bit encroaching on the next part. So 50% of both the boys and girls spend less than 35 minutes on their homework. So I'd say that was true. Okay, question number 14. Cool question. A movie critic rates movies on a scale of 4 stars, excellent, to 1 star, worthless. A summary of her ratings for 20 movies is shown in the table. Okay, so there's a total of 20 movies. So the first one with 4 stars is going to be 3 out of 20. So in order to convert that to percent, 20 goes into 100 times 5. So 3 times 5 is going to be 15. So 3 out of 20 is 15% of the movies getting 4 stars. 7 out of 20, again, just take that, multiply by 5, because that's your conversion. So it's 7 out of 20 is going to be 35%. 6 out of 20 is going to be, 6 times 5 is 30%, and 4 out of 20 is going to be 20%. If the critic rates a total of 100 movies, what is the best prediction for the number of movies she gives for each rating? A, 15 movies with 1 star, 35 movies with 2 stars. Okay. It doesn't seem like these numbers are close enough together. That one doesn't seem good. Letter B, 20 movies with 1 star. Oh, that's exactly what we had. 4 out of 20 is 20%. So if it was out of 100, it would be 20 movies. So 20%. 30 movies with 2 stars. That's exactly what we had. 30 movies for the 2 stars, 30%. 35 for the 3 stars. Oh, we're rocking it. And 15 with 4 stars. Yep, 15%. Okay, so this one looks really good. Let's mark it, but let's double check the other two. 24 movies with 1 star. 26, 27, and 23. Those are too close together. That wouldn't rate out. 40 movies with 1 star. So they're like multiplying by 10. 60 movies with 2 stars. 70 movies with 3 stars. And 30. But they said it's out of a total of 100 movies. So that's already 100. So that's too big. So looks like our choice B is just right. Mark that and move along. Question 15. Last question. The Student Council wanted to find out which sports were most popular in school. A random sampling of 25 students were chosen from the whole school population of 450. These students were asked to vote for the sport they liked the most at school. The results are shown in the table below. Okay, so we have all these numbers. Well, let's just take an example. Use these sample data to calculate the popularity of sports listed in the table for the whole school population. So if we were just to take an example of 3 out of 25, what would that equal out of 450? Well, 4 quarters in $1, 16 quarters in $4, 2 more quarters in 50 cents. So 25 times 18 is 450. So 3 times 18 is 54. First question says, about 54 students in the whole school like basketball the most. Well, that was basketball. 3 out of 25 equals 54 out of 450. So yep, that's true. Part 2. 36% of the whole school population would vote that they do not like any of the listed sports. 36%. Boy, none? Let's see. 36%. Well, none is listed as 2. So 2 out of 25% means out of 100. So 2 out of 25, 25 goes into 100 4 times, so 2 times 4 is 8. That equals 8%, not 32% or 36%. Forget that. No, that's false. Only 8%. So that's false. Question 3. Over half of the school population would vote for football as the most popular sport. Football. Football is 8 out of 25. Well, 8 out of 25 isn't half, so that's no good. Forget that one. False. And last, the same percentage of students like cross-country and track and field as baseball or softball. So this is kind of weird. Cross-country, I went up and looked, and it was 1, so I put a 1 underneath it. And track and field, like these are the two choices combined together. Cross-country and track and field are kind of similar in that you run them on the track, and they're things that maybe in my head go together, so maybe in some other people's heads they go together, and you need to have a good track. Track and field from up above is 4. So if I put these two together, because it says and, this is kind of more just like because this is all one name, track and field, but cross-country is one thing, and track and field is another thing. Cross-country was 1, track and field is 4, so together that makes 5. Compared to the same percentage of students like cross country and track and field as baseball or softball. Well, again, baseball or softball is its own whole thing. It's not in a separate category. Baseball or softball is 5 people. So this is 5 compared to 1 plus 4, which is also 5. The same percentage of students like cross country and track and field as baseball or softball. That's true. 5 here, true. Now, last thing. At the end of your test, you may want to go back and think about any questions that caused you trouble. We had some difficulty back on number 5. And I'm going to look at it again. We didn't have a definitive answer. We were trying to look for, of these statements, choose 2. I wish it was choose 3, because we had A and C and E that we all thought were true. So that would have been great if it was 3, but it says choose 2 correct responses. The theoretical probability of all 3 coins landing on heads is 1 out of 8. That's true. 1/2 times 1/2 times 1/2. So I feel confident with that one. But these two, I started thinking about it a little bit more. And who am I to say that Eva's experiment is flawed because of the theoretical probability? All the times that we rolled the dice in the different classes, everybody had different times that the number 7 came up, different times that the number 2 came up. So an experiment being flawed, that's not nice to say for Eva. She followed her experiment. She kept her data. Eva's experiment is flawed because the theoretical probability of heads and all 3 coins of heads on all 3 coins is different than the experimental. Well, it's going to be different. Experimental probability is different than theoretical probability. So I'm going to change my answer. That's my reason. Who am I to say that this is flawed? I'm going to say, forget that answer. I'm going to say that this is just fine. Eva found the experimental probability that had all 3 coins land on tails to be 1 out of 5. Well, she said 2 out of 10 times, so 2 out of 10 does equal 1 out of 5. So it's true. She found it to be 1 out of 5. That's what she found. She was testing it out. That's what she found. I'm going with A and C. And that is how you're going to be doing your CASP test. That was modeling of all 3 of the interim tests. None of the kids have ever had this before, so I know that you guys are going to do a rockin' job on this CASP test. So look forward to it. Give your best energy and effort. Be sure you get some good sleep tonight. Have breakfast tomorrow. And on all the testing days for the next couple weeks. And you will be amazing. Woohoo! Get them for you! All right. See you tomorrow. Bye.